Do you think that reducing pesticides in agriculture is a new trend? Would it surprise you to learn that the approach has been practiced in Canada for 50 years?
In Canada, it began in Nova Scotia in their apple industry at the end of World War II, when they were more or less pushed to develop a cheaper way of growing fruit, and they developed what they called a reduced pesticide program. And they developed a system of taking advantage of beneficial insects, mites, what have you, and also at the same time reducing pesticide use in their orchards. The program was cheaper than a completely insecticide or chemical control program, and it was adapted by the growers there and it's still in use there. Modifications of it are ongoing now.
Here in Vineland in Ontario, an integrated pest management program, or IPM, for peaches was developed and introduced in the mid-70s. The program initially cut pesticide use in half, but recent advances make it possible to do away with a whopping 75% of the pesticides that would normally be used.
One of the key things about IPM and integrated controls and that sort of thing is the use of multiple approaches to controlling pest species, particularly those which we have to have high levels of control, like direct pests of fruit, like the oriental fruit moth.
The fruit moth's larval or caterpillar stage is the real culprit. Keeping them from being born is the strategy. The female moth communicates her mating readiness with pheromones, chemical cues that we can't smell, but which the male fruit moths find irresistible. Science has turned the moth's allure into its undoing. Scent glands are removed from the female moths. From these, pheromones are extracted and collected. Based on the samples, scientists can synthesize the pheromones that are particular to any given species. When the moths are about to mate, pheromone-laced dispensers are placed in the orchard, permeating the air with the scent of female fruit moth. The males are ready to mate, but can't locate the females in the saturated cloud of pheromone. Mating is disrupted, and most of the moths die before they can reproduce. Fewer destructive caterpillars to ruin the fruit means less pesticide spraying.
The advantage of using pheromones is that we can eliminate additional 3/4 of the insecticides that we would normally apply for oriental fruit moth control.
Aside from the fruit moth, there are secondary pests in orchards.
There are good mites and bad mites. The European red mite is a little red guy who feeds on foliage. Then there are the predaceous mites, and it feeds on the European red mite. It does much better under a system where we're not using a lot of insecticides.
Less pesticide means that more of the beneficial insects survive. There's also a better chance that insects won't develop resistance, so that when pesticide is necessary, it still works on the target bugs. In an ongoing effort to keep one step ahead of the pests, Agriculture and Agri-Food Canada scientists continue to investigate new possibilities for biological control.
The future of IPM, I'm hoping, will include more biological controls, such as the fungus that I'm working with. It's a natural insect disease. It only takes a single spore from the fungus to land on the cuticle, or the skin of the insect, and then it germinates and penetrates through the cuticle inside the insect, and the fungus grows and basically fills the body of the insect, killing it in the process.
The fungus, though lethal to bugs, is safe for other animals in the environment. Still being studied, it may be an approach that's integrated into IPM programs in the future.
I think that there is abundant evidence to tell us that we can't rely on one technique or one approach. So we need to truly integrate more approaches into our field programs. There's a lot of basic science still to be done before we can say, we've got a long-term sustainable system and we can all go home. These ecosystems continually evolve as well, so they're ongoing. The research is ongoing.